Hey guys, welcome back to my channel Pirai Academy. In today's video, we are going to see about Leetcode question number 33. Search in rotator sorted array. So there is an integer array nums sorted in ascending order with distinct values. So this is so much important. Okay. Prior to being passed to your function, nums is possibly left sorted at an unknown index k, such that the resulting array is like this. Okay, let me explain you this. For example, if 0 to 7, this is one of the array. If it is left rotated 3 indices, then it will be like 4, 5, 6, 7, 0, 1, 2, which means first of all, this 0 will be coming to this end. Okay, which means one rotation. In next rotation, this 1 will be coming. In next rotation, this 2 will be coming. Okay, like that. Okay, given the array nums after the possible rotation and an integer target, return the index of target if it is in nums or -1 if it is not in nums. Okay, fine. So first of all, what is meant by rotation? Let us see that so that you can understand this. So rotation. So here they have given like 0, 1, 2, 3, 4, 5 and 6 and 7, right? Now for 3 rotation, for first rotation, this one will be coming, sorry, this 0 will be coming to here, which means now the array something looks like this. Can you understand this? After 3 rotation from the initial array, then at third rotation it will be like 0, 1, 2. These values will be coming to the that side row, the ending, which means 3, 4, 5, 6, 7, 0, 1, 2. That's it. After 3 rotations. So initially it will be like 0 up to 7. Now after 3 rotations it will be like this. Can you understand this? So this is what rotation means. So this is a easy thing, right? Now let's get into the logic part. So what is the first thing that comes into your mind? The brute force approach. So what is the brute force approach? So let me copy this so that it will be helpful in future. Okay, so what is the brute force approach? So the brute force approach is just to do a linear search. Okay, so I'll be starting from here. Okay, now whether this 0th index, this 4 is equal to the target 0, no. Now whether 5 is equal to 0, no. 6, no. 7, no. 0, yes, then return as 4. Okay, if for example they have given the same array, but the target is something like 9. If they given the target as 9, now what should I do? I will be just traversing like this. So whether 0th index is equal to 9, no. 4 is not equal to 9. 5, no. 6, no. 7, no. 0, no. 1, no. 2, no. 3, no. So anything is not equal to this 9. So at this particular point, what I am supposed to do? I just return -1. Can I understand this? So now tell me, what is the time complexity? So time complexity will be O of n, because we are traversing the entire array only one time and we didn't took any auxiliary space, so it will be O of 1. But whether we can still optimize it, because there is a word. What is that word? Rotated sorted array. Because the array is sorted initially, but that we have done some k number of rotation. So it is a rotated sorted array. Whenever there is a keyword called sorted, we want to think in terms of binary search. I already told you, whenever there is a term called sorted, we must be going and checking whether we can do in terms of binary search. So let's begin the approach. So this is the array, and let's take the target value is 0. Target is equal to 0. Now initially, what is the first rule of the binary search? So I will be placing a pointer here, and this will be my lower limit and it will be my upper limit. Okay, now how to find the mid pointer? So mid is equal to L plus U divided by 2, or mid is equal to L plus U minus L divided by 2. So always use this second thing. Okay, if you are not using Python. Okay, because whenever it goes to the maximum integer value, then this method will be helpful and it will be giving you the correct answer. Okay, fine. Now, so mid is equal to what? Here 0, plus 7 divided by 2, which is equal to 3. So go to the 3. So this is going to be my mid at initially. Okay. Now whether the 7 is equal to my target. No. Then I should check whether I will be moving towards the left side or towards my right side. That's the basic understanding of that's the basic core logic of the binary search, right? So now I want to decide. Okay. So just check whether this lower limit value is what? 4. Is 4. And middle value is what? 7. Okay. I'm just checking whether this 4 is less than the 7. Because it is in a sorted order, but it is left rotated some k times, right? Here it is rotated 4 times, but we don't know how many times it is rotated. But in our by seeing this we can tell that. But in terms of code, in terms of logic, how we are going to find is just check whether this lower limit value, this 4, is less than the 7. Yes, which means everything will be particularly in sorted order. Can you understand this? These things will be always in a sorted order, correct? Yes. Now I'll be checking whether the 0 lying between 4 and 7. No, right? So obviously I want to move towards the right side. So I'll be making my lower limit towards here. Can you understand this? Yes. Now again, what is the mid value? Mid value is going to be 5. So here it is mid. Okay. Now whether 1 is equal to the target 0. No. Okay. Now at this point, what should I do? Whether I want to go towards the left side or I want to go towards the right side. Let's check. Okay. So here it is 0. Here it is 0. Now just understand this logic. Here it is what? 0. So 0 means what should I do? I just go towards the left side because 0 is lying in between 0, 1, right? Between the lower limit and the mid, right? So at this particular point, I want to move towards the left side. Towards the left side means make u to mid minus 1. Now where my mid lies? My mid will be at this particular index called 4. Now whether this fourth index element is equal to the target. Yes, 0 is equal to 0. So I'll be returning 4 as my value. Can you understand this? Okay. So let me take another example. Okay. Now let's just go with another possibility. Target is equal to 9. Okay. So 9 is not here, right? So how this algorithm works? So initially here comes L and here comes upper limit. Now what is the mid? Mid will be 7. Okay. So the target value, the 7 and 4. So 4 is less than 7. 4 is less than 7, and I want to check whether my target value is between them. No, it is not between them, right? So obviously, where should I move? I should move towards the right side. Okay, move towards the right side. Okay, fine. Yes. Now again, what is the mid? Mid is this 1. Whether this 1, yes, 0 is less than 1. This L pointer, the 0 is less than 1. Yes, it is, yes, but 9 is not in this particular range. So where should I move? Towards the right side. Okay, towards the right side, which means L is equal to mid plus 1. Okay. Now what is the mid? Mid is 2. And L is also 2. Whether it is the 9 is between 2, 2. No. So go towards the right side. Right side means mid plus 1. So which is here. So both are lying at this particular point, 3. So mid is equal to 3 and lower limit is also equal to 3. So whether between these, this target is there? No, right? So again, move my lower limit to plus 1, which means lower limit will be particularly at 8. So my lower limit is greater than my upper limit. At this point, I should be terminating the loop and I'll be just doing what? Returning -1. That's it. Can you understand this? Yes. So this is how it will be working. So this is how the logic also. Once I am going with the code, you can understand this clearly. Now tell me, what is the time complexity? So the time complexity will be O of log n, because we are using a binary search in which either you will be not going towards the left or you will not going towards the right, which means you will be eliminating half of them. That's the reason why you are getting log n. And what is space complexity? It will be O of 1, because we haven't used any other auxiliary space. Now let's get into the code. So here's the Java code. If you want the Python or C++ code, you can go and search in the description. Okay. So see here, left is equal to 0 and right is equal to the last element in this. Okay, now while left is less than the right, which means when the lower limit is lesser than or equal to the upper limit, then only I want to do this set of looping. Otherwise, I will be terminating, right? That's the thing I have already told in the drawing explanation also. Now, mid is equal to left plus right minus left divided by 2. You can either use this, or if you are using Python, there you can use left plus right divided by 2. Okay, both are similar. Okay, fine. Now, if my nums mid is equal to target, then what should I do? I'll be returning that mid. Okay, now else I have two possible values. What are those? Either my mid value is greater than or equal to the left, this condition, else my left value is greater than the mid value. Yes, so these are two conditions I have. So inside the first condition, what I am going to do, I again checking whether the target is under this range, like from left to mid. So under this range, whether my target is there. If my target is there, then I'll be doing what? Right is equal to mid minus 1, which means I am moving towards the left. Okay, else where should I go? Towards the right, which means left is equal to mid plus 1. So now comes to the else part. So see here I want to check whether my target is in between the mid and the right. Target is in between the mid and the right. If it is so, then only I will be doing what? Left is equal to mid plus 1, which means I am going towards the right, because my target is from mid to right, which means it is on the range of mid to right, which means it is lying towards the right side. So that's the reason I am going from left to mid plus 1. Can you understand this? The left is assigned to mid plus 1, right? Now else I want to go towards the left side, which means I'll be making my right pointer to mid minus 1. After everything, I'll be returning minus 1. That's it. So this is the entire code implementation. Let me submit it. Yes, it is submitted successfully. If you really like this video, subscribe to my channel. And if you want to know about these kinds of algorithms, just go and search in my YouTube channel. And if you have some doubts regarding this video, you can comment below. I'll be commenting it out. Thank you.